Okay, so today we are trying to understand what are the different type of resistance forces in the form of resistance when the vehicle is trying to move. There can be forces which are longitudinal, lateral and vertical, and when the forces are acting, the longitudinal forces, lateral forces or vertical forces will be all together working, and it is not that they are working independently, but they are working in totality. All three of them are working at the same time. But for the sake of studying, we have to decouple all the forces, and we would understand that we are not having all the three forces working, but we are going to have one of the forces which are working. So first thing is to decouple and study in isolation for any one type of force. So let us look at this figure, and we understand that there is a vehicle which is trying to climb on the inclined plane, and as it is moving, my hand is also moving. So as it is moving, so this is the angle of inclination, this is the center of gravity, and this is the weight of the vehicle, Wmg is there, and we have a point B which is said to be the front wheel. We have a point A which is said to be the rear wheel, which is two, one on the front and the back, front and back, two wheels are there, but we are showing the elevation, so we are able to see only one wheel. And then we have a distance which is measured from B, the front wheel, and the rear wheel as total L. So L is the combination of L1 and L2. So the distance from the front wheel to the center of gravity is L1. It is written in the center, which is wrong. And the distance of center of gravity to the rear wheel will be L2. It may not be necessarily equal, but we have to take it separately if we need to study for later classes. Maybe not useful right now in this class, but I'm just trying to tell you. Then we have heights of the different position, and we have the center of gravity. The height of the center of gravity to the road is, say, h. The height of the force which is acting because of the air movement when the vehicle is trying to move. So this is the resistance shown by air, which is known as aerodynamic resistance. So RR is said to be aerodynamic resistance when the vehicle is trying to move in this direction. This is the direction of the movement. Okay. And then we have forces which we say that if this vehicle is also having another trailer in between. Sometimes when we move, we try to help somebody. So if any other trailer is attached, so FD is representing a force which is acting on the vehicle if it is trying to move away along with the trailer. So you can have it or you can delete it. There is what we can think about. Now when the vehicle is trying to move, then what will happen is that when the vehicle is trying to move, there is some force which is acting between the tire and the road, both in the front wheel and in the rear wheel. So that type of force which is represented by this arrow and this arrow in the front wheel and the rear wheel will be represented by FF or FR. So what is FF is the front wheel tractive force, and FR is the rear wheel tractive force. I forgot. So the height of the force which is acting for the trailer which is being attached, that is SD, and height of the point at which the aerodynamic force said to be representing at a certain point is HA. So HA is the height of the point at which the aerodynamic force is acting. So these are the nomenclature of the forces, and we have the component of the force, which is W cos theta and W sin theta, as we have studied in your engineering mechanics course. Now let us go to another part. There are certain codes which are used. So there is an ISO 855 or DIN 7000 code which says that there is a certain practice which has to be followed when we are trying to understand the vehicle movement. And if we have X direction, the direction with the vehicle moving, there's a Y direction and the vertical, and this Z direction, then X direction, this type of movement, in the X direction. So these are the movement which are said as to be positive. This is positive and this is all positive. So any movement in the X direction will be known as rolling, said to be roll. The vehicle movement of the vehicle in the X direction will be said to be roll. So if the vehicle is moving, we say it is rolling. And if there is any particular movement because the vehicle moves in the Y direction, but that will be known as pitching. You already know that. And the movement of the vehicle in the Z direction, will be known as yawing. So we have rolling, pitching, and yawing. So we are right now thinking about rolling only, and that is study in the X direction. Now, talking about rolling, that is the movement of the vehicle, we have resistance to the movement of the tire. So if there is a force which is generated for the sake of movement known as traction force. So the traction force, as I said, this is the rolling force, or the traction force front wheel and traction force back wheel. So in order to see that, then we will say whenever there is an action, there is a reaction also. So there is a reaction which is known as rolling resistance, which is opposing this movement of the vehicle. Okay, so when we have rolling resistance, then we have to slightly understand how is rolling resistance related with the tire. Rolling is related with the tire surface and the road. So tire plays a very important role, and tires generally are made up of rubber, and rubber are nothing but elastomers. Now we have materials which can have different type of property. For example, if we have springs, then springs are elastic. If you load it and unload it, there is a certain way in which the spring will move. The force and the stress and strain diagram will be a certain pattern. And if we have a certain friction, then we have there is a certain formula for that. And if we have a force which is because of the viscous fluid, then we have a certain symbol. So these are the symbols which are used for elastic, friction, and viscous forces. So if we see now that if we want to define an elastomer, so elastomer is a combination of elastic material as well as viscous material. So if these two are there either in parallel or in series, this type of material representation is known as elastomer. Similarly, we can define any metal with the help of its elastic property and its frictional property, and this type of representation in series and in any combination will be known as metal. So these are different methods of representing materials. Okay, so we know that what is a tire? Tire is not only elastic, it is elastomer, so it is viscoelastic material, and it has got viscosity and elasticity both, which is there. So keeping that into mind, we will come to the stress-strain diagram of elastic material, that is elastomers. And if we see elastomers, then if we have elastic material, then what will happen is this loading, the stress will increase and therefore strain will be there. So this curve of loading will be there. I have written elastic material, which is wrong, but I wanted to say it was elastic. So supposing if it's an elastic material, then this line will go up, and if we unload, that this line will be same followed and it will be going back. So that is the property of an elastic material. But if we have an elastoplastic material, that is an elastomer, which the tire material or rubber is, then what will happen is that when we put a stress on the tire, then this is the way in which the loading process or the stress increases and the strain is there. That is the elongation or compression takes place. But when we unload it, when we unload a elastomer, that is a tire, then what will happen is the unloading will not be in the same elastic way, but it will be in an elastomer way. And that elastomer way, that it will not follow the line, but it will be following a certain line like this. So this is a certain line which is a unloading line for a tire of a automobile. So if we see that this is the unloading of elastomer material or the rubber, then we see that there is a certain area which is shaded here and shown here. This is a certain amount of strain which is remaining even when the stress has gone away. So this strain which is remaining and this type of energy which is being lost, shown in the shaded portion, is known as what? Hysteresis loss. You must have read about hysteresis loss in material science. So this loss of energy is taking place because the rubber or the tire material is an elastomer. So now certain amount of energy which has been applied by the tractive effort, that is the tractive force which is trying to move the vehicle forward, and when the tire is moving, always a certain amount of loss is taking place because of the tire material. So the tire material is causing a certain loss of energy, which is known as the hysteresis loss. Now coming to this residual residual strain. So residual strain is when the tire has been unloaded, there is still a certain amount of strain which is remaining, and that strain is not always remaining, but it goes back. The direction is in this direction. This is the direction in which the strain moves. Without any load, it goes back and reaches the same spot as if it was an elastic material. So this decrease of strain, the coming to zero, that is the residual strain, will finally go away as the time passes. So if we see any rubber or any sponge type of material, if you press it and then you leave your hand, then what will the sponge looks to be compressed for a while, but after some time you will see that that sponge is now becoming of the same shape as it used to be. So it takes a certain amount of time for the elastomers to regain its shape, but that is a certain amount of time which is used. So what I mean to say is that the residual strain will go, and that will go with time, and it also is dependent upon what is the frequency of which you are loading and unloading it. So if you are continuously loading it and unloading it, then the residual strain will have a certain way of redoing its residual strain. So this residual strain will take time depending upon the time it takes, depending upon the material and depending upon the frequency of which rate of loading that is taking place. Okay, having that into our knowledge, we need to now understand that there is a tire and there is a certain tread. So the increased elevated portion of the extended surfaces of the tire, which we see there is a gap in between and there is a design, that extended surface is known as tread, T-R-E-A-D, tread. And we see that there are a number of but if we see the wheel and we see the road, then there is one tread here which is exactly on the bottom of the radial thing which is contact with the road. This particular tread will be most compressed. So if we look at it, then there is a okay, that I have explained. Now this pressure with which the tread are compressed depends upon what is the contact portion with the road. Those treads which are not in contact with the road will not be pressed, but those treads which are in contact with the road when it is still, this movement I have shown is not to be there. It's a still vehicle, so the wheel is just still, your vehicle is just standing, and when it is standing, then the treads in between from here to here region will be under compression, and the tread in the center will be under highest compression. So the distribution of the pressure from here to here will not be same on the treads. It will be different for different treads, and there is where we now have a terminology called contact patch of the tire. So contact patch of the tire is actually the pressure distribution of on the treads which are in contact with the road. Therefore, this will be at the highest pressure, and the adjoining treads will be lesser, and finally there will be a tread which will be free of pressure. Now, this pressure distribution can be seen in the front view, that is the elevation that we see when we are standing in front in the door side of the vehicle. We can see from here, and we can see it in, that is, it can be 1D representation as I am doing it here. It can be 2D representation of the pressure. You can have it this way and that way, or we can have a 3D pressure distribution curve that you can make, that is known as contact patch of the tire. Okay, knowing that, if we have a tire which is stopped and we see, then we will see that this is the curve which is being made, and this curve is representing the pressure acting on each of the treads, and this is how it looks like. This is the contact patch. So the pressure distribution curve is like this. It is highest in the center, and lowest at the touching end, and rest of the treads are not having any pressure. This is when the vehicle is stationary, so that is important. And the tires are definitely pneumatic, and they have pressure which is air filled with a certain pressure. So that pressure generally is 32 psi or 35 psi, depending upon what is the front wheel or rear wheel or type of vehicle. But if we have a truck, then we can have 120 psi also. So that is using FPS unit still, and wherever we go and we say to fill our air in the tire, we are actually talking in PSI. We are not talking in SI unit. Okay. Now, if we look at the same thing when the wheel is not stationary but wheel is rolling, wheel is actually moving. When the wheel is moving, then what will happen is, this is moving, and if we see this at the center of the wheel, and we think that this is the weight of the vehicle, weight which is going down, and this is the point at which the maximum pressure is there, would have been there, and then we will say that this is the normal reaction. So this is the normal reaction which is when the vehicle was stationary. Now if the vehicle is moving, the rotation is taking place, then what will happen is that the one which is loading, you see this curve represents the loading curve, and this curve represents the unloading curve. So if we see that this tread is now going under loading, and then it is highly loaded, and then it is unloading, you see, so loading curve is higher, unloading curve is lower. So for any particular value of the strain in the vertical line, if we draw, then for the same strain we will see that the loading has a higher stress and unloading has a lesser stress. This means we just cannot draw as we have drawn it here that the loading and unloading was same. This is loading and this is unloading, but in this case where the wheel is stationary, Here the wheel is moving, the car tire is moving. So when it is moving, the loading curve will be having higher values of stress, and the unloading curve will be, from here it is unloading starts, isn't it? So from here the car tire will be having lesser stress compared to loading one. So this will not be the same shape. The shape will get distorted, and it will be larger here and smaller here. You see, the smaller here will push in. So if we see what is the final resultant force which is acting, we see number of forces acting, but if we see the resultant force acting because of the contact patch, that is the pressure distribution, then we will come to understand that this normal reaction, which is representing the resultant reaction of all the forces which were there, then we will definitely agree that this resultant force will not be here but will be here. It will be here when the wheel is rolling. It is not when the wheel is not rolling. The wheel is stationary, it will remain in the same line. But when the wheel is rolling, it will come to the left hand side, the direction in which the vehicle is moving. So what will happen is this force will not be in line to the center of this weight which is there. And if it is not in line with it, then there is a certain distance through which these forces are acting. So one is moving downward, other is moving upward. So this is the resultant force because of the rolling, which is now not in the line with the center of gravity, and this is the weight of the vehicle. So what will happen is there is a certain moment which will be created, and this moment will be not in the direction of the rolling moment, but it will be in the opposite direction of the rolling moment. Now if you have understood that, then we are trying to track, we are trying to move the vehicle. The movement is known as tracking, and when we are trying to track, then there is a resistance offered in the form of moment, which is because of the disturbance of pressure patch, contact patch, and this particular disturbance has created an anti-clockwise moment which is opposing the movement. This anti-clockwise movement force, this moment is nothing, it is an opposing moment will be created. I am writing an opposing moment will be created. This created opposing moment is known as rolling resistance. It is a resistance offered in the form of moment which is not trying to allow the vehicle. It is the resistance towards the rolling of the vehicle or tracking of the vehicle. No, so we now have to clearly understand that rolling resistance is nothing but the disturbed patch. So if we see that if there is a force Fr, what is the Fr representing? The rolling resistance. What? Okay, so Fr into R. So Fr into R will be equal to the opposing moment. That is what I have to say. And if you see it in another direction, then we will say that Fr is also equal to rolling resistance coefficient into W. So we have, this is W, this is not N, this is W. Okay, so rolling resistance is dependent upon the type of tire that you're using, material. Fr is the rolling resistance coefficient. Okay, and that rolling resistance eats up the frictional force, it eats up the tracking force. So and it is when we are trying to move, this rolling resistance is actually opposing the movement of the vehicle. So if we see here, this is the tracking force and this is the rolling force. This rolling force is opposing the movement of the vehicle, and therefore we have now you must be knowing it in an interesting manner that if we are rolling, and when we are rolling and suddenly we want to try and apply brake, then when we are trying to apply brake, this rolling friction, this rolling resistance, it aids in braking. It aids in braking. So rolling resistance is an aid when we are trying to apply brake on the vehicle. I will try to contact you again on my next lecture further to extend this particular topic. Thank you for listening.